Our lesson today is solving equations with variables. Our objective is that we can rearrange an equation for a given variable. There may be times when we might have equations that contain more than one variable, and we may want one particular variable to be the one that is isolated. So let's get started. Again, when we're solving these, we want to use inverse operations, opposite operations, to get the variable that we want by itself. In other words, to isolate the variable. Let's take a look at the first one. Our first example is an equation that says d plus c is equal to a. Our directions say that we want to get the c by itself to solve for c. So what we want to do is to get rid of or move the d. Since the d is positive, we're going to use opposite operations. We're going to subtract d from both sides. Well, d minus d is 0, so that now leaves me with the c by itself. And on the other side, we'll have our expression, which is a minus d. Our final solutions when we are going to get a certain variable by itself will simply be expressions. We won't necessarily come up with a numerical answer. In the next example, we want to solve for m. So since m is being multiplied by p, we're going to do the opposite operation, and we're going to divide both sides by p. P divided by p is 1, so that leaves me with 1m, and that equals k divided by p. Now we have the m by itself. In our next example, you may see that we have y equals mx plus b, a very familiar equation to you, and in this case we want to get the x by itself. So the first thing we're going to do is to subtract b, doing the opposite operation. So I have y minus b is equal to mx. And now to get the x by itself, I want to divide both sides of the equation by m, which is the opposite operation. So the expression that I have remaining is y minus b divided by m is equal to x. And I have the x now by itself. In our next example, we're going to solve for b2. We have a lot of things we need to do. We have a equals 1/2 times the quantity b1 plus b2 times h. There are several ways to do this. Here's what I would do first. I want to get rid of the 1/2. Well, I could divide both sides by 1/2 since I'm multiplying by 1/2, or I could multiply both sides by the reciprocal, which is 2 over 1 or 2. So my result is 2a, 2 over 1 times 1/2 is 1. So now I'm left with b1 plus b2, that quantity, times h. Now what I would like to do is to get rid of this h. It's being multiplied times the parentheses, so what I'm going to do is divide both sides by h, which is the opposite operation. Now I have 2a over h is equal to b1 plus b2. And since that's the only thing that I have left, I'm going to take the parentheses off. Our final step, I want to get the b2 by itself, so I'm going to subtract b1 from both sides. So what I'm left with is this fraction 2a over h, and I'm going to subtract the b1, and that's going to be my result of b2. Lots of steps, but if we do one thing at a time, and then we can isolate the variable, should be good. Alright, here's our next example. We want to solve for b. So the first thing I might want to do is to try to get rid of the 1/4. Now again, we could divide both sides by 1/4, or what we could do is the opposite operation. Instead of dividing by 1/4, I'm going to multiply by the reciprocal, which is 4/1. So that's going to leave me with 4y is equal to 4/1 times 1/4 is 1. So I'll have 1 pi bh. Our goal is to get the b by itself, and b is being multiplied by both pi and h. So I'm going to do the opposite operation. Instead of multiplication, I'm going to do division, and I'm going to divide both sides by pi and by h. So my result will be 4y divided by pi h equals b. And now I have the b by itself. Here's our next example. Y plus 5 equals 4/5 x minus 9. Well, if I want to get the y by itself, I'm going to have to move that 5. But before I do so, I need to do the distributive property so that I have my terms separated instead of and getting rid of the parentheses. So I have y plus 5 is equal to 4/5 x minus 36/5. I might want to not have the 36/5 when I'm working with these numbers. I might want to change my 36/5 to a mixed number. So if I have 36/5, I would take 5 into 36, which would go 7 times with 1 left over, and now I have my mixed number. That's going to help me because now I need to do the opposite operation to get the y by itself. So I have y equals, remembering 5 minus 5 is 0, I have 4/5 x, and negative 7 1/5 minus 5 is going to give me negative 12 1/5. So when we want to solve an equation where we are simply getting a variable by itself so that we have another expression, we are solving it just like we did the other equations, but there may be little or no numbers to work with. And our job is to isolate the variable using inverse operations. Please finish your notes and then continue with the reflection.